So an interesting thing that happens or that we can calculate when it comes to changes in temperature is how much heat we need to change the temperature of a certain substance, okay? So what helps us determine that is something called a specific heat. So every substance has different properties, and you can imagine like a piece of metal gets pretty hot pretty quickly compared to like a bunch of water, right? So the water doesn't heat as quickly as a piece of metal would, okay? Maybe sometimes, I don't know if you've ever been cooking and you might, stir something with a metal spoon or a metal utensil, and all of a sudden it's really hot in your hand. I don't know if that's happened to you, but it's happened to me. So the specific heat is the amount of heat needed to raise 1 gram of a substance by 1 degree Celsius. So I want to be really clear here that the specific heat is just to change the temperature of a substance, okay? Notice there are no phase changes here, right? We're not going from a solid to a liquid. We're not going from a liquid to a gas. We are simply changing the temperature of a substance, okay? And our equation looks something like this. Q tells us our heat. This is usually in calories or joules, is equal to the mass, so mass in grams of our substance, times, and now here this is C sub P, so this is our specific heat. The interesting thing here with specific heat is that I've seen it represented several ways. In your Top Hat course, it's a lowercase c, okay? Here it's a capital C subscript P. I've seen it in textbooks where it's SH for specific heat. So just be aware of that. And we multiply that times a change in temperature. So this is a good way to tell if we're talking about a change in temperature or a phase change. Later on, you'll see that for phase changes, there is no change in temperature component. So if you are using this equation, it's because you are changing the temperature of a substance, okay? So water has the highest specific heat of any substance. Okay, so what can we do? Who cares? We can answer questions like this. How much heat, Q, and usually again, heat is expressed in calories or joules, but how much heat is required to raise the temperature of a 500 gram piece of aluminum from 20 degrees Celsius to 100 degrees Celsius? Let's see. And then you always kind of need a table of specific heats to answer these questions. So there's our equation from the previous slide. Let's start plugging it in. So to get delta T, to get delta anything, a change in anything, it is always final minus initial. This can be really confusing because sometimes people don't know how to figure out that change in temperature, but it's always what you ended up with minus where you started with. So we're ending up at 100 degrees Celsius. We started at 20 degrees Celsius. So it's 100 minus 20, it's 80 degrees Celsius. That's our change in temperature. Our specific heat, we got to get from the table. And so this is, we're just raising the temperature of aluminum. So we want to look, aluminum is 0.22. We also want to make sure we're paying attention to our units. This is calorie per gram degree Celsius. All right. And then our mass is this 500.0 gram piece of aluminum. So we plug all those in, just plug and chug from here. So 500 grams goes in for our mass, the value from the table goes in for our specific heat, and our change in temperature goes in for delta T. Notice that our grams will cancel with this grams in the denominator and the units of specific heat. Also degrees Celsius will cancel with degrees Celsius here and that change in temperature. Again, this is our units of specific heat. So you'll see we'll be left with the units of calories. And if we multiply all our numbers, we get 8,800 calories or 8.8 kilocalories. This is a little heating curve. I love this table because it really emphasizes that when we are going through our phase changes, there is no change in temperature. Notice temperature is graphed on the y-axis and the heat being added in is on the x-axis. We often mix up heat and temperature. Remember, heat is a form of energy, of thermal energy, either being put into a system or taken out of a system. Temperature is just a measure of a property, right? What is the current temperature of that water or whatever you may be working with? So again, if we add heat to a solid, it warms up, warms up, warms up. And if this is solid ice, it warms up. And once it gets to 0 degrees Celsius, it's going to melt. While it is melting and turning into liquid, there's not a change in temperature. It stays at 0 degrees Celsius. So you have some ice at 0 degrees Celsius and you have some water at 0 degrees Celsius existing at the same time. Then if we continue to add heat into the system, that water, the liquid we created, will also start to heat up, heat up, heat up, heat up, heat up. And when we get to 100 degrees Celsius, now that liquid will start to boil and change into steam, right? It's going from a liquid to a gas. Again, it's going to stay at that temperature. Some of the water existing at 100 degrees Celsius and some of the steam existing at 100 degrees Celsius. But while it's going through the phase change, remember there's no change in temperature there. Again, and we can continue to add heat if once we have all the liquid going to gas, and the gas can then go up in temperature.